Let's talk about left cosets and right cosets and normality of subgroups using the affine group as an example. Here we are talking about the affine group of the real line, which can be interpreted as matrices A, B, 0, 1 with A non-zero and B any real number. And remember that it has this multiplication and inverses. The affine group has subgroups H and K described as above. And let's see what the cosets, the left cosets and the right cosets are for H and for K. And stay until the end for a visual representation of these cosets. Let's begin with the left cosets of H. Take G to be a generic element of the affine group, and then GH will be every element that is G times an element of H. So if you multiply those matrices, you get this matrix, and since Y is running over all the real numbers and A and B are constants and A is non-zero, this AY plus B runs over every single real number. So GH is matrices of this form where A is fixed and Z is any real number. Let's now look at the right coset. So HG will be any element of H times that fixed element G, which as you multiply the matrices, you get A, B plus Y, 0, 1. Now, Y runs over all the real numbers, so B plus Y runs over every real number. So HG is also A fixed, any real number, 0, 1, which is what GH was. That means that for any G, HG and GH, the left coset and the right coset coincide, and that is, by definition, the definition of H is normal in G. H is normal in the affine group. Now let's try to find what the left cosets and right cosets are for K. G times K will be matrices of the form Z times B, 0, 1, where Z runs over non-zero real numbers and B is fixed. However, when you try to compute KG, what you get is matrices of the form AX, BX, 0, 1, where X is running over all non-zero real numbers, but that means that BX divided by AX, so this corner divided by that corner, is always constant B divided by A. So that means that it's matrices X, Y, 0, 1, where X, Y are points in a line Y equals B over AX, with X non-zero. So, in particular, this is not GK. So the right cosets and left cosets do not coincide in general, and therefore K is not normal in the affine group. We can interpret these cosets geometrically as follows. The affine group is matrices A, B, 0, 1, so we can represent these matrices in coordinates, the A coordinate and the B coordinate. For example, when A is 1 and B is 0, we get the identity matrix, so the identity is right here. The subgroup H is matrices 1, B, 0, 1, so it's this line. And for a generic value of G, A, B, 0, 1, the coset GH is equal to the coset HG, as we proved, and it's those matrices A, Y, 0, 1, as Y runs over all the real numbers, so it's equal to this line here. Now, K is the set of matrices X, 0, 0, 1, so it's the x-axis. The coset GK was matrices of the form X, B, 0, 1 with B fixed, so it's that line. But the coset KG was a line of slope B divided by A, so they look like this. And then you can see that GK and KG are not the same. So K is not normal, but H is.